All right, here we go. Reading, writing, and evaluating expressions. Now, um, we have hopefully beat order of operations to death, and we are ready to apply expressions with variables. So the goals we have is to write expressions with numbers and variables. Okay. Evaluate expressions at specific values of their variables, and we'll talk about what that means. And then I can use variables to represent numbers and write expressions for a real world situation. Okay, so there are some terms that you need to know and understand and apply, and we will be using this vocabulary. Okay, so this is parts of an expression. So this expression reads 3x minus 10. The coefficient is the number to the left. I'd also say in front of the variable. Oops, spelled variable right. Okay. Okay. A term, okay, is separated by an operation symbol. A constant is a number all by itself. So a number all by itself. A variable is a letter representing an unknown value. Okay. Now, when reading and writing an expression, it's important to look for keywords to indicate whether to use certain operations. Okay. So we have, there's lots of words. There's lots and lots and lots of words that we can use for this. And, oh wait, go back up here. I was thinking, hang on, the coefficient, I meant to, would be the 3. Sorry about that. So the number to the left or in front of the variable. The term, we're going to circle the terms. 3x is a term, 10 is a term, because they're separated by an operation symbol. Constants are numbers all by themselves. When we say constant, it's something that it just never changes. Okay? And then a variable is a letter. So this is my variable. Okay? A letter representing an unknown value. So think of some words that would signify what you're going to signify an operation. For example, adding would be, let's say, all together. Some. I'm just going to give you a few on here because we do have those posters at the front of the classroom and we'll have more discussion. Okay. You can even Google. You can even, if you're at home and you have to do this by yourself, you can Google what are some words that mean subtract. So difference. You could say less than or even more than. Multiplying product. Of. That's a big one. Saying of. Multiply. Again, we'll get more. We'll get more off the board. Dividing. Okay. Finding the quotient. And you could say divide. Split. Okay, there's just a few words. Okay, so right here where it says using keywords, expressions can be written multiple ways. Okay, so there isn't always one way to write an expression. And so this one, I have 5x minus 10. You could say 5 times a number, because remember, we've talked about this a couple of times. Whenever you see a number next to a variable or a number next to a parentheses with no operation, that means you're going to multiply. So right here I have a coefficient in my variable stuck together with no operation means multiply. So 5 times a number minus 10. So we could say minus. That says difference, okay? Or you could say 10 less than 5 times a number. So you're flipping it. And we're going to talk about what is so significant about the phrase less than and how we use it. So we're going to draw a line connecting each algebraic expression to the matching expression. So I look at these, but I'm going to come over here and look at my written expressions with the words. 6 less than 3 times a number. 6 less than. Now notice when I say less than, and we're going to go back to this guy up here. 10 less than 5 times a number. So less than means subtract, but if you see in my expression here, we switched it. 10 came first, but it was less than 5 times a number. So 6 less than, I'm just going to circle this. 6 less than. So something minus 6. Something minus 6. And if you go and look, there is a minus 6 and a minus 6. But let's look at this. 6 less than 3 times a number. So less than 3 times a number. See, this is different. This is, we are finding something in parentheses and then multiplying. But here, 6 less than 3 times a number. The quotient of a number and 3 plus 6. So when I use the word and can also mean adding, okay? So the quotient of a number and. So and is adding. So let's look for things that have adding. Well, there's 2. So the quotient of a number, and 3 plus 6. The quotient of a number, oh, that's division down here. It's so tiny. Okay, so this is the only one that has division, so it must be that. The product, what does product mean? It means to multiply. The product of 6 and a number minus 3. Okay, the product of 6 and a number minus 3 would be this one right here. Triple the difference between a number and 6. So triple also means multiply. So we'll put triple up here. But look how this is worded. Triple the difference between a number and 6. It's almost like saying we're going to triple, but we're going to do this first. So what do you think that looks like? Yeah, our first one. So the difference between a number and 6. Difference, a number and 6, okay? And then 6 times a number plus 3 would be this one right here. Okay, so down here we're going to rewrite each expression using numbers, variables, and operations. And like we're seeing, there are multiple ways of doing this, so we've got to kind of use our words and play with it. 25 less than. I'm going to box that less than. First of all, I know it means subtract, okay? And in this expression, the front and the back, they're going to switch places. So something minus 25, okay? 25 less than 3 times a number. So I'm not going to use x because x can also look like multiplying, and we're trying to transition how we use that variable. So we're going to say n for number. So 3n. So 25 less than 3 times a number. Now you are not going to write 3xn, like 3 times n. we are dropping that. From moving forward, whenever you're working with algebraic expressions and you're multiplying, you have a coefficient and a variable, that's how it's going to be, so that we always know, oh, when I see that, that means multiply. Double the difference of a number and 5. So I'm going to double this, but first I got to find the difference of a number and 5. So it's kind of like doing this, right? And difference, subtraction, order matters. So when you say difference, the first thing in your expression, number and 5. So I'm gonna, it has to go in this order. And double, what does double mean? Yeah, times 2. So we can come back up here and add the word double. Double. Okay. Move on to the next one. So, but now we're going to look at this right here. We're going to evaluate, meaning to solve. So to evaluate an expression, use substitution when the value for the variables are given. Evaluate each expression when x is going to be 4, so x equals 4, y equals 2, and z equals 3. So you have learned order of operations. And now we are combining that skill with algebraic expressions, and we're giving values to our variables. So x to the power 2. You must do your work and show your work as I'm teaching you, so that if you make a mistake, I can help you. So x to the power 2. Well, x equals 4. So I'm going to rewrite this. 4 to the power of 2. And make sure it looks like a variable so we don't misunderstand and think it's just the number 42. So 4 to the power 2 is the same thing as 4 times 4, which equals 16. Look at this we do. 3x plus y. X equals 4. Y equals 2. So when I rewrite it, I'm going to do it like this, because I know my coefficient and my variable stuck together with no operation means multiply. So I'm going to put that parentheses. We have seen this with order of operations. Okay, so that still means multiply. Plus y, which is 2. Now, thinking about order of operations, see how this all kind of comes together. I have multiplication and addition. Well, what comes first? Yes, multiplication. So 3 times 4 is 12. Then I'm adding 2, and I'm getting 14. Okay. You do. Well, you're not here with us, and this is new, so I'm going to do it with you. Z minus y. Z is 6 minus y is 2 gives you 4. Okay. Then I have z to the power of 2 minus x to the power of 2. Z is 6 to the power of 2 minus x is 4 to the power of 2. Now, some people would say, I don't know, which one do I do? Well, it doesn't matter. You have exponents, then you have subtraction. So you could do both of these at the same time. So 6 times 6 is 36 minus 4 times 4 is 16, which gives you 20. All right? Now, we're going to combine it. It says write an algebraic expression to match the words and then use substitutions to evaluate. And I'm just sending Mr. Snyder. So the sum of 2 times a number and 5. So the sum means to add. 2 times the number is 2n, multiplying a number and 2 plus 5. So we're writing the expression first. And then they're saying the number, the value is 8. So now I'm going to write 2 times the number 8 plus 5. I have multiplication and addition. 2 times 8 is 16, and then adding 5, and I get 21. Okay. The we do. 4 added 2, triple the difference of a number and 7. The number is 10. So triple the difference of a number and 7. Now, if you look at our first page, we had 2 examples of this. So 3 times, but it's saying first I have to find the difference of a number and 7. Order matters. So number came first, minus 7, and then 4 added to that. So added 2. Okay? My number is 10, so I'm rewriting my expression, giving my variable a value. So I have 3 times 10 minus 7. Remember, parentheses is first. So 3 times 10 minus 7 is 3 plus 4. Then I have multiplication and addition. My order of operation says multiply first. 3 times 3 is 9 plus 4 gives me 13. And then you do the last one. So 15 deducted from 5 times a number plus the product of 4 and the same missing number. Well, deducted from is the same thing as saying less than. So, which means this is going to go at the very, very end. So something minus 15, okay? 5 times a number plus the product of 4 and the same missing number. Let's start with 5 times a number. So 5 times a number plus the product, which is still the same thing, means multiply, the product of 4 and that same missing number. Okay? So I'm going to move this guy over. All of that. Okay? And they're telling me that n is 5. So n equals 5. Okay? So 5 times 5 plus 4 times 5 minus 15. I have multiplication, addition, and subtraction. My order of operations says multiply first. So I'm going to say 25 plus, and multiply these two, 20 minus 15. My order of operations, at this point, remember addition and subtraction are combined. So we work when all we have left is addition and subtraction, work left to right. 25 plus 20 is 45 minus 15, and then I get 30. It's a lot, but we're going to get the practice on.